Flipped classroom video for Maths AS Unit 1, Factorising cubics. This video very much leads on from the video about the remainder and factor theorems. And the main point of it, at least for the moment, is that we can use the factor theorem to help us to factorise polynomials. And why do we want to factorise polynomials? Well, if nothing else, this is very useful for finding roots of polynomials, and roots of equations are where the equations are equal to 0, and this can be very useful mathematically but also in applications. So, if we can find a value so that P of A is 0, then we know that x minus a will be a factor. The best way to look at this is with an example. So let's have a look at one. P of x is 6x cubed minus 13x squared plus x plus 2. And so you may ask yourself, well, how do we find a value that makes that 0? Well, the easiest way to try is to start with 1 and then have a look at minus 1 and then 2 and so on. So let's do that. We try these values. So what is P of 1? Well, if we replace x by 1 in this equation, we're going to get 6 times 1 cubed, which is 6, 13 minus 13 rather, times 1 squared, which is minus 13, plus 1 plus 2, and that comes to minus 4. So because we're looking for 0, that's no good to us. Okay, we'll try minus 1. Pop that in, we get 6 times minus 1 cubed, and of course minus 1 cubed is minus 1 itself. We get minus 13 times minus 1 squared, and minus 1 squared is plus 1. Then we get one lot of x, which is minus 1, and then we get plus 2. And when we work that out, we end up with minus 18. So again, that's no good to us. Now, because of the space left on the page, you're probably guessing that the next one might work, but let's have a check of it anyway. So we have P of 2. So that's going to be 6 times 2 cubed. Take away 13 times 2 squared, plus 2 plus 2. Now the positive terms there are 6 times 2 cubed, which is 6 times 8, which is 48. 48 plus 2 is 50, plus the other 2 is 52. And the negative terms are 13 times 2 squared, which is 13 times 4, which is also 52. So we have 52 take away 52, which is 0. So we can say a big hooray because we have P of 2 equals to 0, and therefore we know that x minus 2 is a factor of P of x. So that means we can conclude from here that P of x is equal to x minus 2 times ax squared plus bx plus c. Now we know it's a quadratic because the degree of our original polynomial is a cubic, so the degree is 3. And we know that when we multiply polynomials we add the degrees. So because x minus 2 has a degree of 1, that's the largest power of x is x to the 1, then the other factor must have a power of 2, because we need 1 plus 2 to give us our degree of 3. So, and there it is written down, so degree of the other factor is the degree of the original polynomial, take away the degree of our divisor, or our factor. Okay, so we've done loads it feels like, and we've still got more to do because we don't know what A, B and C are. So next we're going to find them. Okay, so this is what we know so far, and there are different ways of finding A, B and C, but they all essentially use the idea of comparing coefficients. So the coefficients of each part of the function, the functions rather, must be the same for the functions to be the same. So what that means in another way is saying that the multiple of x cubed must be the same on both sides of the equal sign. The multiple of x squared must be the same, the multiple of x must be the same, and the constant must be the same. And there are various ways of doing this, but one method is just to multiply out the right hand side. There are quicker methods, and your teacher will probably look at those with you, but one method that will definitely work nice and easily is just to multiply out the right hand side. So we have x minus 2 times ax squared plus bx plus c, and that gives us, when we times it by x, we get ax squared times x is ax cubed, bx times x is bx squared, and c times x is cx. So there we are. and then we're going to do minus 2 times the right hand side. We're going to line them up again like we have before. So minus 2 times ax squared is minus 2ax squared. Minus 2 times bx is minus 2bx. And minus 2 times c is minus 2c. So add them all up and we get ax cubed. We get b minus 2a times x squared. We get c minus 2b times x, and we get minus 2c. Now what we can do is we can put the coefficients of each part equal to each other. So for x cubed, in the original we had 6, and in the new one we have a. For x squared we had minus 13 for the original polynomial, and we have b minus 2a for our factorised version. For x we have 1 equals c minus 2b, and for the constant we have 2 equals minus 2c. And we can solve these equations. So we might number them so that we can see what we're dealing with, and we can straight away see from equation 4 that c is equal to minus 1. We can then use that value of c in equation 3. So equation 3 is 1 equals c minus 2b, but because we know that c is minus 1, we can say that it's equal to minus 1 minus 2b. That means that 2b is equal to minus 2, which means that b is equal to minus 1. And then we can use equation 1 straight away. That just tells us that a is equal to 6. Now you'll notice we've used 3 of those 4 equations, so this is a really good opportunity to do a check. If we've got these numbers right, they must work for equation 2 as well. We see that we have b minus 2a, and if we put the values in that we've just calculated, then they should then give us the minus 13, and if they don't, we made a mistake. So if we pop in the numbers, b is minus 1 and a is 6, so we have minus 1 minus 2 times 6, and that is indeed minus 13, which tells us that we've probably got this right. And so we now have ax squared plus bx plus c equals 6x squared minus x minus 1. So we've now done a load more work, and we're still not finished, because what we know is that our original polynomial is equal to x minus 2 times 6x squared minus x minus 1, but if we want to fully factorise it, we're going to have to factorise this quadratic. So we need to factorise 6x squared minus x minus 1. Now you already know how to do this, but for completeness in the video we'll do this on screen, as it were. So a common technique for this would be to times the coefficient of x squared by the constant. So that's going to give us 6 times minus 1 is minus 6. We then look at the pairs that multiply to give us minus 6, and we know that these are going to give us our minus x coefficient, so we need the bigger number to be negative. So we've either got 1 and minus 6 or 2 and minus 3, and we need the pair that adds up to the minus 1 that x is times by, and that is of course 2 and minus 3. So the next line is we split our minus x into plus 2x minus 3x. The x squared and the constant stay the same, and we can now in pairs factorise these. So the first pair of 6x squared plus 2x, we take a factor of 2x out, which gives us 2x times 3x plus 1, and for our our minus 3x minus 1, I should say, then we can take minus 1 out to give us 3x plus 1. Put them together, we've got 2x minus 1 times 3x plus 1, and finally we are there. We know now that p of x, which was 6x cubed minus 13x squared plus x plus 2, is equal to x minus 2 times 2x minus 1 times 3x plus 1. Now if we look at a sketch of that, we can see that it's crossing the axis at 2 at 0.5 and at about a minus a third, and in fact these are the numbers. Each of those makes one of our brackets equal to 0. So if we had the factorization and we needed to sketch this curve, we could have marked those points onto the diagram and then we could have drawn the curve through them. So that's what I was talking about by saying that factorizing helps us to find the roots of the equation, which is a useful thing.